Okay, so let's start with our next topic now. Okay, so the next topic that we are starting is angle properties. Angle properties on for a line, angle properties of polygons, angle properties of parallel lines. That's what we want to do today. And the time that we are left with, it's a fairly straightforward concept. It's not going to take that much time. So let's discuss this now. So there's some things that you need to know about angles. First of all, if you have a point, at any point, the sum of all angles is 360. Let me write that down here. Sum of all angles at a point is always equal to 360 degrees. Now, what does that mean? If you have a point like this, and there are different angles at this point, so let's say we've got different lines coming out of that point. Like this. And now you are given, so this is the point, right? And you know that this is 90 degrees. And let's say this angle here is 150 degrees. This angle here is 100 degrees. What about this value? What about this angle x? Now, how do you find this angle? Sum of all angles at a point is supposed to be 360. So what you can do is you can just, these are all angles at a single point. You just add all of them up. X plus 100 plus 150, and this is 90, right? This should equal 360. And that will give you the value for x. You can see what that is. 260 minus 240, that's 20 degrees. The value of x turns out to be 20 here. Okay, so at a point, sum of all angles at a single point, that is always equal to 360. Okay, now sum of angles at a point on a straight line. Sum of angles at a point on a straight line. That equals 180 degrees. Now, what does that mean? If you have a line like this, a straight line, and there's a point on this line, let's say there's this point here, and at this point, you have different angles. You have one line coming out like this. You have another line coming out like this, and you know that this angle is 80 degrees, let's say. This angle here is, let's say, 30 degrees, and you want to find the remaining angle in the middle. Now, these are angles on a straight line, right? So we have a straight line, and these are angles on that line, above that line, at a single point. This is the point that we're talking about. Their sum is always going to be 180 degrees, right? So it's half of 360. The total would be 360. Half of that is 180. If we add all of them up, the result should be 360. So x plus 8, result should be 180. So x plus 80 plus 30, this should equal 180. We can find the value of x from this. That's 180 minus 80 minus 30. And that turns out to be 70 degrees. So the value of x should be 70 degrees. So sum of all angles at a point on a straight line, that is always equal to 180 degrees. All right. Okay. Now, the next is vertically opposite angles. Vertically opposite angles. Now, what do they look like? Vertically opposite angles. Vertically opposite angles are equal. Vertically opposite angles are equal. Now, what are vertically opposite angles? If you have two straight lines, you have one line like this, another line like this. Okay, I'm sorry, just give me a minute. I'll connect my charger quickly. It's at risk right now. Okay. What are vertically opposite angles? If you have two straight lines and you have one angle on one side of this point of intersection and another angle on the other side of this point of intersection, these two angles are going to be equal to each other. If this angle is x, this is also going to be x. These are called vertically opposite angles. On a straight line, at the point of intersection, the angles that you have on the opposite sides, they're equal to each other. So if this angle is x, this is also x. And if this is y, the angle on the other side, that's also going to be y. Okay? So the opposite angles are equal. These are called vertically opposite angles. All right. Now there are some properties. Now there are some properties for angles formed with parallel lines. Now these are some general properties before the ones that we did before. Now, what about angles on parallel lines? Angles with parallel lines. Okay. Let's think about this. The first type of angle that we have, the first set of angles that we have that are equal here, we call them corresponding angles. Now, you need to know these names because you have to give explanations of whatever you're doing in the exam as well. If you're taking two angles to be equal to each other, you need to write down that these are corresponding angles. That's why they're equal. So first of all, corresponding angles. Now, what are corresponding angles? Corresponding angles are angles like this, that if you have two parallel lines, if you have a line like this and another line that is parallel to that first line, these are two parallel lines. And there's a third line passing through these parallel lines. So let's say that line is going like this. Okay. Now, this angle here and this angle here, angles on the same side of the line, these are corresponding angles. If this is x, this angle here is also going to be x. These are corresponding angles. These correspond to each other, right? Because these lines are parallel, they have the same direction. If this angle is x here, this is also going to be x. These two are known as corresponding angles. Now, you could also look at it from another perspective. If this angle is y, then this is y. These are also corresponding angles, right? Angles on the left side above one parallel line, and on the other parallel line, these two angles, they are also going to be equal to each other. These are also corresponding angles. Okay. And you could get some other sets as well. For example, this angle here and this angle, these are also corresponding with each other. These are vertically opposite angles as well. This one and this one, right? But we could also say this now, that this angle here and this angle here, these are also corresponding angles. Okay, these are called corresponding angles. Then we have alternate angles. Now, what are alternate angles? Alternate angles on parallel lines, they are going to be on the other side, like on the other side of each other. For example, if you have two parallel lines like this, and again you have a line passing through those two parallel lines. Like this. Again, you have two parallel lines, and you have a third line passing through these parallel lines. If you have this angle x here, this angle here is also going to be x. These two angles, these are called alternate angles. These are called alternate angles. You can kind of remember it like this, that if you make a Z using the parallel lines like this, a Z-like shape, the angles on the inner side of the Z, these are alternate angles. Okay, the angles that are on the inner side of Z, these are called alternate angles. Look at the difference with corresponding angles. Corresponding angles were on the same side of that third line. If this is X, right? They were equal to each other. Alternate angles, they're on the other side of the line. One is on the right, the other is on the left. These are alternate angles. These are also equal to each other. The reason for this is these are alternate angles. Okay. So when you say that this angle here is equal to this angle, the reason that you would give there would be that these are alternate angles. That's the second type of angle, that second thing that you need to know here. And then there's something that we call interior angles, co-interior angles, and they look like this. These are called co-interior angles. If you have, again, the same set of parallel lines there, okay, I'm finding it hard to erase all of that. Okay, I think I'll just draw another set. Let me copy from here. Okay, so we have another set of parallel lines again, and there's a line passing through those parallel lines like this. Now, another way to look at these angles is we look at this interior angle here and this interior angle here. These two angles, both of them are inside the parallel line. So notice the difference. In corresponding angles, both the angles that you have, they are both above the parallel lines. So this angle X is above the black line. This angle X is also above the black line. And they're also both on the same side of the third line. They're both on the right side and right side. Compare that with co-interior angles. One of these angles is below one parallel line, the other is above that parallel line. So these are the angles between the parallel lines on the same side of the line. Angles, let me write that here as well, between the parallel lines on the same side of the third line. So they're on the same side of the third line, and these are between the two parallel lines. These two angles, they always add up to 180. X plus y, this is always equal to 180 degrees. If you know one of them, you know the other is going to be 180 minus that. And it's not just true on this side, it's also true on the other side. If this angle is y, this is x, these also add up to 180. These are called co-interior angles. These angles add up to 180. All right. Now, these terms are important. You need to remember what corresponding angles are, what alternate angles are, and what co-interior angles are. Okay, you need to be able to differentiate between the set. But apart from the reasons Just remember, when you have two parallel lines like this, and there's a line that's passing through those two parallel lines, you would get 8 angles in total. You get 8 angles in total. You have one angle here, another angle here, you have another angle here, and you have another angle here. These are 4 angles, and you have another here, another here, another here, and another here. You have 4 acute angles and 4 obtuse angles. All the acute angles are going to be equal to each other. So if this angle is x, this is x, this is x, this is x. If this is y, this is y, this is y, this is y, using all of those properties that we have discussed before, these two y angles, these are vertically opposite, right? These are vertically opposite. This y and this y, these are alternate angles. This y and we already discussed that. This x and this x, these are alternate angles. This x and this x, these are corresponding angles. This x and this x, they are vertically opposite angles, right? But eventually what happens is all acute angles are equal. When you have a situation like this, two parallel lines and a third line passing through those two lines, all acute angles are equal. All acute angles are equal. And all obtuse angles are equal. All obtuse angles are also equal. And there's some, because of the co-interior angles property, there's some x plus y that is equal to 180. These two add up to 180. So when you have two parallel lines and a line passing through those two parallel lines, all the acute angles are going to be equal to each other. All obtuse angles are going to be equal to each other. And the sum of one acute angle and one obtuse angle, that is going to be 180. So these are some angle properties that you need to know of. Angles at a point are equal to 360. Angle on a straight line at a point, that's 180 degrees. Vertically opposite angles are equal. Then we have angles with parallel lines in which corresponding angles are equal. Alternate angles are equal. Co-interior angles, they add up to 180. And in general, using all of those properties, when you have two parallel lines and a line passing through those two lines, all acute angles are equal, all obtuse angles are equal, and their sum for one acute angle and one obtuse angle, that's 180. Okay. Now in the next class, we will do angles in polygon along with a couple of other concepts as well. But since we're running out of time now, we cannot start, although we cannot start polygons right now. Let's do one quick example in which we might have to use these properties that we have just discussed. They're going to be used in circle properties later on as well. So in the next class, what I'm thinking of is that we also discuss the circle property. So we get done with angles then, so all the circle theorems. So we started with angles right now. So in the next class, what we can do is we can discuss angles in a polygon and also angles in a circle. All right. But for now, let's quickly have a look at one example at least on these angles that we've just discussed. Okay, let's do this. In the diagram, EAF is a straight line. EAF is a straight line. And AB is parallel to CD. AB and CD, they're parallel to each other. AB bisects FAC. Bisect means it divides it into two equal parts. AB, what's AB? AB is this line. They're saying this line AB, it bisects FAC. What's FAC? FAC is this complete angle. Okay, this is complete angle. AB is bisecting that. If we know that this angle is 58 What about the other angle here? That's also going to be 58. Why? Because they're saying AB is bisecting that. So this is also 58. We need to first of all find the value of x. Now, how can you find that? This is a straight line. What about angles on a straight line? They add up to 180. So we can say x is going to be equal to, or you can write it like this instead. Let's say x plus 58 plus 58, that should equal 180. And then x equals 180 minus 58 minus 58. And that should give us the result. That should be 64 degrees. And that's the value of x that we get. Okay. Now, what about the value of y? Where is y? This is y. We have parallel lines. In parallel lines, remember, corresponding angles are equal, alternate angles are equal, and the sum of co-interior angles, that is 180. Now, how can we think about this? One way to think about this is we have these two parallel lines. If this angle is 58, what about this angle? Can we figure this out? Let's call, or let's not call it anything, but these are co-interior angles, right? These are co-interior angles, angles between the two parallel lines on the same side of the line, of the third line. Their sum has to be equal to 180. 58 plus this should be 180. So can we write down the value of this angle at the bottom? This is going to be 180 minus 58. That is 118. And then angle in a straight line, 180 minus 118. That will give us this number, which is going to be 58. That's one way to think about this. That's a longer way. Or you can directly start here. You have this parallel line and this parallel line, and a line passing through this like this, passing through these two parallel lines like this. This is 58. This is below the parallel line. This other angle below the parallel line, this is also going to be the same. Which property do we use here? Why are they equal? These are corresponding angles. If this is 58, this is also supposed to be 58. We could write that directly as well. That is 58 using corresponding angles. Now, in this case, they do not ask us to write down any property. Sometimes they ask us to write down the properties as well, in which case you need to remember the name of that property like this. That's 58. The first angle was 64 degrees. Okay. Let's have a look at one more quickly, if I can find one here. This is on polygons again. Okay, let's try this. In the diagram, the lines BA, DC, and EF are parallel. You can see that here. ABC is equal to 140 and BCF is 115. You've got everything given in the diagram. First of all, you need to find the angle DCB. Okay, DCB. What's that angle, DCB? That's this angle here. Okay, now how do we think about this? What is this angle going to be? We can extend the parallel lines like this. We have this, this, and this. All of these lines are parallel to each other. Let's extend that parallel line above. That will make it easier to understand. These are two parallel lines. If this angle is 140, there's a line crossing like this, right? If this angle is 140, this angle here is also going to be 140. Alternate angles. This angle and this angle, they are both alternate angles. So the angle DCB, that's going to be 140 degrees using alternate angles. What about DCF? DCF, what is that? DCF, that's this angle here. How do you find this? One way to do this is that we say angle at a single point is 360. Sum of all angles at a point is 360. So if this is 140, this is 115, what is the remaining angle going to be? This one. This is going to be 360 minus 115 minus 140. 360 minus 140 is 220. 220 minus 115. 220 minus 100 is 120. 120 minus 15, that's 105. This should be 105 degrees. Okay, that's what we get. EFC. EFC. Okay, that's this angle here. What about this? We have these two parallel lines. Again, that orange angle above, we found that to be 105 already. These two are co-interior angles. Their sum has to be 180, right? So what about this angle at the bottom then? This would be 180 minus 105 using co-interior angles property, and that gives us 75 degrees. So this angle is therefore 75 degrees. Okay, so this is how these properties are going to be used. You can do more practice in this. I'll be uploading a worksheet in this today on polygons. You cannot do all questions yet, but after tomorrow, you should be able to do all questions in this. We will do polygons, angles in a polygon tomorrow, along with circle properties, angle properties of circles, inshallah. Okay, so that's it for today. I'll see you again in the next class. If there are any quick questions, let me know. Otherwise, we end this here. Any problems, anyone? No problems? Okay. All right. I'll see you again tomorrow then. Allah Hafiz.